Okay, we're getting very close to the end of the Module 8 lab activity. I'm going to step you through parts 3 and 4 of the activity. Notice we'll be using a different interface for part 3, and it's actually called the PHY interface. And so there's a link in the student guide. You can either type it in or click on it, but it's going to take you to a website that looks like this one. In fact, it may pop up a little in another frame. If not, what you need to do is click on the ASSA detected sunspot groups on SDO HMI continuum. Sounds very complicated, but really this is just an image that shows the current sunspot groups on the solar face. Hopefully you've got some sunspots on your date. If not, if you're doing this activity when the sun is not active, ask your instructor to provide you with dates of a little more activity. But fortunately, from my image, I see there are some sunspots. Terrific. So that at least shows me that this thing is working. Now, the first thing we need to do is we need to create a movie in order to get a feel for the motion of sunspots across the solar disk. What you do is you click on the little movie icon in the lower right hand corner of your screen. So there's my current screen. I click on movie, and it's going to build a little 10-frame movie. And it's pretty quick in doing that. And you have a slider which allows you to move from left to right, and you can kind of get a feel for the motion of the sunspots. However, that's only 10 hours worth of data, so it's not enough information. So what the instructions tell us next to do is to make a larger movie. And the way you do that is you click on the little arrow next to the timestamp. When you click on that, you actually see some options. You want to increase your number of frames from 10 and increase it up to 120. That's going to give you essentially 5 days worth of data. Remember, 5 times 24 is 120. So since these are hourly reports or hourly images, this will give you 5 days worth of data. And you're going to wind up with something that looks like this. I take that back. It's going to look like this, which is 5 days worth of data. Again, it's going to take maybe a little bit of time to render. Oops, no, it doesn't look bad either. Apply. So it's going to take a little bit of time to render. It comes up pretty quick from on my internet connection. And there I've got 5 days worth of data. And the nice part is now I can slide from left to right and see and get a better feel for the motion of the sunspots. Now what the lab instructions or the student guide tells you to do is to track the motion of one particular sunspot. Pick one. Doesn't matter which one. But you do want to make sure that one choose a sunspot that is to the left of the center and it finishes to the right of the center. And try not to get too close to the edge of the sun. And make sure that it persists the entire time. So I could choose this particular sunspot, 2172 perhaps, and first of all move it from left to right and make sure that it does indeed persist the entire time. It appears that it does. And so now I just kind of keep an eye on where it's located at the start with respect to these longitude lines. I don't care the actual value of its position, but I do care about how many longitude lines it crosses during its 5-day journey. And so I'm just going to keep an eye on that, remembering that each longitude line, or each pair of longitude lines, is separated by 10 degrees. And so by watching how many longitude lines my particular sunspot crosses will tell me how far the sunspot moves in a period of 5 days. And so you do that and you answer a couple of questions. Finally, the last part that you need to do is you're actually going to click on a pre-built movie. And this is what the movie looks like. So you're given a link to a pre-built movie which shows the motion of two sunspots, numbers 1959 and 1960, and asks you a couple of questions about their respective motions. So hopefully this whole activity has given you not only a feel for the sunspot cycle, the fact that sometimes the sun is quiet, sometimes the sun is active, but it's also giving you a feel for the motion of sunspots across the solar disk. And of course that is influenced by the differential rotation of the sun. So once you've done the activity, you've done your student guide, you've answered the lab quiz, I do want you to go ahead and take the post-test. That's very, very important. You took the pre-test before you did this lab activity. Now I want you to take the post-test and show me what you know about sunspots now that you've done the activity and how that compared to your knowledge coming in. So it's very, very critical, again, to assess the quality of this activity that I get your feedback. So please do take a few minutes, take a 5-question post-test, and hope you enjoyed it. Thank you.